We are going to start the chapter 1 of class 8, that is rational numbers. To start the chapter, first of all, we must know what is rational number. The definition of the rational numbers is the numbers which can be expressed in the form of p upon q, where p and q are integers and q does not equals to 0. So we must know what is integers. Integers are the whole number with their corresponding negatives including 0. But in the case of rational numbers, denominator cannot be 0. Some of the examples of rational numbers are 5 upon 7, where 5 is the numerator and 7 is the denominator. And next example is minus 2 upon 3. Now we'll discuss the types of the rational number. There are two types of the rational numbers. First one is positive rational numbers, second is negative rational numbers. There is very slight difference between these two. First one says that if the rational number is having both numerator and denominator are of same sign, then it will be a positive rational number. We can see the example. It is written minus 2 upon minus 3. Numerator is minus 2, denominator is minus 3, both are negative. So it is a positive rational number. In the same way, 4 upon 9, both the numerator and denominator is positive, so it is a positive rational number. On the other hand, negative rational number, we can see the numerator and denominators are not of the same sign. As an example, we can see minus 2 upon 3. So the numerator is minus 2, which is negative. Denominator is 3, which is positive. Another example, we can see 4 upon minus 9. Numerator is positive. Denominator is negative. So these are the example of negative rational numbers. Now we'll see how we can add the rational numbers. So for understanding the addition of the rational number, there are two cases. First case, which says that when the two rational numbers which we want to add are having the same denominators, in such cases only we need to add the numerators and denominator will remain same. We can see one of the example. In the example, it is written 2 upon 5, which is the first rational number. Second rational number is 1 upon 5. On adding this, numerator of both means 2 and 1 will be added. So 2 plus 1 become 3 and upon 5. So 3 upon 5 is the result. Now we'll see the second case with the different denominators. That means when the two rational numbers are having different denominators, how we can add them. For adding the rational numbers with the different denominators, firstly we need to make the denominators same by finding their LCM. Then it can be added as usual, means as we have done in case 1. We can understand it with the help of an example where we have taken two of the rational number. First rational number is 5 upon 12 and second is 1 upon 20. The denominator of first rational number is 12, second rational number's denominator is 20. The LCM of 12 and 20 is 60. So what we'll do now, we'll change 5 by 12 as denominator 60 and we will also write 1 upon 20 as denominator 60. For doing so, what we can do, we can multiply 5 upon 12 by 5 with the numerator and denominator. We'll get the result 25 upon 60, and if 3 is multiplied in the numerator and denominator of 1 by 20, we are getting 3 by 60. So now we are having two rational number, 25 upon 60 and 3 upon 60. There we can see both the rational numbers are having the same denominator, that is 60. So now we'll add the numerator. The numerators are 25 and 3. When it will be added, it will become 28. So our answer will be 28 upon 60. We can cancel it and write it in the simplified form. So it is cancelled by 4 and we have written it as 7 upon 15. Now we will discuss the properties of rational number under addition. The first property is closure property, and it says that for any two rational numbers, if the rational numbers are considered it as a and b, then the sum of the numbers, that means a plus b, will also be a rational number. We'll clarify it with an example. There you can see in the example 2 of the number 1 upon 2, which is the first rational number. Second rational number is 1 by 4. If these two are getting added, the result is 3 upon 4. So the sum of two rational number 1 upon 2 and 1 upon 4 is 3 upon 4, and our result, that is 3 by 4, which is also a rational number. The next property which we are going to see is commutative property, which says that for any two rational numbers a and b, a plus b is equals to b plus a. That means we can change the order of the rational numbers while we are adding them. We can understand it with an example. Here we have taken a as minus 8 upon 13 and b is taken as 23 upon 27. Now what we'll do, with the help of these two numbers, we'll prove that a plus b is equals to b plus a. So first of all, a plus b means minus 8 upon 13 will be added with 23 by 27. This is the second case of the addition of the rational number where the denominators are not same. So first of all, we'll find its LCM. For doing so, we are multiplying both. So the LCM is 351. So on adding minus 8 by 13 plus 23 by 27, the LCM is taken 351 and we have got the result 83 upon 351. On the other hand, when we are adding 23 upon 27 and minus 8 upon 13, that means we are changing the order of the number. In that case also, we'll get the same result 83 upon 351. So it is proved. Next property is associative property, which says that for any three rational numbers a, b and c, the sum of the three numbers, if the numbers are taken in the different order, will remain same. So here it is written in bracket a plus b plus c. That means in this case, first we will add a and b and the result will be added to c. And this overall result will be same as if we are adding the b plus c firstly and then the result will be added to a. We can understand this with an example where we have taken a as 2 upon 3, b is equals to 4 upon 5 and c is equals to minus 5 upon 6. So it's LHS, which is a plus in bracket b plus c. So we are adding b plus c first. On adding b plus c, we have put the value of b is 4 upon 5 and value of c is minus 5 upon 6. On adding these two, as we can see, these are the rational numbers with the different denominator. So we have taken out the LCM of 5 and 6, that is 30, and then we have got the result of it as minus 1 upon 30. Now this minus 1 upon 30 will be added with 2 upon 3, and by taking LCM we have got the result 19 upon 30. Now we are changing the arrangement. Earlier we have added b and c firstly and the result was added to a. Now we'll add a and b firstly and the result will be added to c. Now we'll put the value of a is 2 upon 3, value of b is 4 upon 5 and value of c is minus 5 upon 6. Okay, so the a and b is written in the bracket. That should be solved first and we'll get the answer as 22 upon 15. And when we'll add minus 5 by 6 on it, then the result is 19 by 30 again. So now we can see in both the cases the result is same. So the property is verified. Next is addition with 0. It says that any rational number when added with 0 gives the same rational number as result. So we'll consider a rational number as a. If a is added to 0 or 0 is added to a, the result will be a. We can understand it with the help of one example. In the example you can see the rational number is 2 upon 7. So first one we can see, first one is written 2 upon 7 plus 0, means when the 2 by 7 is added with 0, we'll equalize the denominator and then we'll add, we'll get the result as 2 by 7. Same way, if 0 is added with 2 by 7, again we'll take out the LCM and find the sum, which is equals to 2 by 7. So in both the case the result is same. So the property is cleared about a plus 0 or 0 plus a both give result a. Next is additive identity. This says that for any rational number a, there exists its additive inverse minus a, which gives the sum 0. Means for any number there will be another rational number which will give 0 when it will be added to it, and that is called its additive inverse. We'll understand it with an example. Suppose minus 5 a number is given. So if we'll add 5 in it, we'll get the result 0. That means 5 is the additive inverse of minus 5, and in the same way minus 5 is also the additive inverse of 5, because when these two are added they gives the result 0. Another example we can see, 14 plus minus 14 is equals to 0. That means minus 14 is the additive inverse of 14, and in the same way 14 is the additive inverse of minus 14. So we can conclude by saying that the additive inverse of a positive rational number is a negative rational number, and additive inverse of a negative rational number is always a positive rational number. That's all for today. Thank you.